So I'm just gonna kind of go through the um, secret network like quick start tutorial. So this first, I'm gonna assume most everybody is a little bit familiar with smart contracts and some basic CosmWasm stuff. Um, so this is on the secret network docs. I can post some of these links in the Discord too if anybody wants these. Their template contract is like a counter, just a contract that stores a number and you can increment the number and do things like that. Um, and actually, I guess the first thing I should start with is setting up environment. Um, so you need get and make. It's pretty common. Um, this is to get Rust up, which gets your like Rust build environment set up. There's sometimes a little bit particular about which Rust version you use. The one that I've found that works the best recently is 1.69. And then you add this build target here, which this is the WASM that runs on the blockchain, like the build environment or the architecture, I guess. So you have to add that target and you have to add that to your builds to get the right executable at the end. And then there's this cargo generate, which I, in all honesty, have not used cargo generate. They use it for pulling in the template from Git, and I usually just do a clone, which has worked fine. And then you'll need Docker, assuming you want to run it on like a local instance of the blockchain. Deploy locally and run it there, which is nice to see the actual blockchain log sometimes, even though they're quite noisy. And then you'll need SecretCLI. This is the command line tool for you deploy, you push your code to the change, like instantiate it, initialize it, and then you can do all your executes and queries. I always get it from this page here under the Secret Labs GitHub. You usually just grab the latest binary for your environment. And so then you get SecretCLI running, and then you can start the this is probably a little premature to start the Docker, but I like to do it right away. Just go in here and copy paste that. If I can, oh, okay, I already ran it. Oh no. Of course, me running it before screwed this up. Just really gonna. Sorry, guys, I gotta figure out middle of Docker now. I'm not use it that much. Maybe I'll just rename this. Okay, well that worked. Yeah, so this is just the secret blockchain running. You'll just kind of get logs in here as it goes through. So then I'm going to go to the compile and deploy section. So then you can run this command to get the secret template repo set up. But I'm just going to go to the GitHub and clone it. Yeah, so then we're in here. So all the important stuff is obviously under source. you go, so yeah, in here you'll find your contract.rs. This is kind of like where all of the like entry points are, I guess. The primary functions, which they're all got this entry point on it. This is instantiate, which is like the constructor for the contract. So when you store your code, you like put the binary there, and then you like can instantiate multiple instances of it, and pass in different parameters depending on what you want. So this is the instantiate. All this one is doing is it's making the state object, which is like the storage of the contract. So you get your count and the owner, because you have info.sender. This message info will tell you who sent the message, and things like, I think that's the primary thing I use. I actually don't know what else is in there, but that's the most of the like message context. This instantiate message is something that you would define yourself for what data you want in there. So I'll pull that up out of the msg.rs over here on the left. Yeah, so it's just you're basically starting it with the initial number that you want to start the count at. And then you got your execute messages in here and your query messages. I'm going to assume you guys know the difference between queries and executes, which are actual transactions, like sending funds. And then there's all this derived stuff, which basically just makes it JSON serializable and renames everything to snake case. So this increment would be increment. And then get count would be get count, right? So then in here, this does just as a log, and then this is a storage write, which will save it in storage so that you can access it later. I can show you guys what the storage file looks like. Right here, so you have to make these keys so it can like identify it. And this is actually the older format of storages, which is way less pleasant to use. There's a thing called storage plus, and then to define this, you would instead do like pub const config, and you'd call an item, and then like uint 128. Well, I guess this could be count. That makes more sense. Equals item new. And then this is your config key, which should be up here. You could redefine them like that. So that's how you add all the, you add all the storages for things that need to live between transactions, your entire contract state. And then you can read and write to them. Queries only have read capability. And so then this is an execute, which just has two messages, increment, reset. This, one of the most important things here is the way that you interact with SNP20s. So secret network is almost entirely layer 2 or CW20 or SNP20 is what's used, because that's where you get the privacy. Layer 1s can't have privacy because of consensus and things. So it was all built into the layer 2s. So every token has a wrapped version, which wraps it. I'm sure you've seen like the S secret and the S ETH and all that stuff. You wrap it, and then you can interact with the other products. So for this specific like perps, what I always tell everybody is to just ignore layer 1s. Don't interact with layer 1s unless you have a specific use case for it, because it adds a lot of extra code and a lot of extra checks where we don't really want to or need to support them at all. So instead of, because if you've worked with layer 1s before, you get a sent funds field in with your transaction. And for CW20s, it would be, there's this receive message, which has like, the sender, the from, and these fields are almost always the same unless there's an allowance and somebody sends your funds for you. So it can be a little bit confusing, but it'll also send you the amount. And then this is how you handle funds coming in. So if somebody wanted to swap, you would use this message to like, swap into their field because you know what tokens they've sent you, and then you already have the tokens. Because there's also an MSG field that's where you can pass in data like slippage, or if you were opening a position, what your leverage is, anything that's specific to that case. So the SNP20, when a SNP20 is told to send funds to this address, it will call this receive message. But in order for it to do that, you have to register receive on the SNP20, which I will pull up here. So this is the SNP20, this register receive message, because we have, I'm pretty sure the code hash portion of a contract information, there's an address and a code hash, and the code hash basically ensures that you're interacting with the expected executable, right? So that if you know what the right code hash is, you know that the code that you're interacting with is what's expected. So you register receive to the SNP20, and basically that tells the SNP20, this is my code hash. I want you to call receive whenever I get funds. And you can actually have it call your receive without doing this, but then the person who's sending the funds has to enter the code hash in their data, which you can't really expect them to do. So it's good to do this register receive on all SNP20s that you're planning to interact with. And then the other thing that you'll need is, because of the privacy, that we have viewing keys on Secret Network. I'm sure that any of you guys that have used a Secret Network product have experienced the pain of viewing keys. But it's basically just a password that you use to see your own balance, or any user, you can see anyone's balance if you have their viewing key. So if your contract needs to know what its balances are, you're going to want to set one of these when you, either at initialization, if you know ahead of time what tokens you need, or what we do a lot is we register tokens when we want to add them to a contract, which will do a register receive and a create viewing key, and obviously any storage initializations it needs to do. So I don't know if viewing keys, are you guys familiar with viewing keys and register receive and everything like that? Or should I don't want to spend too much time on that if you guys are familiar.
I would maybe highlight it just for a moment, like give a very quick overview of like what their purpose is, or if you have any other introductory material for it. No need to go super in depth.
Yeah. So I mean, it's really just, it's really about the privacy, because basically on the query side, like if I send a transaction, the blockchain knows what the sending address is. So like if I send a transaction to the SNP20, they can verify and know what my address is. So they, I'm authorized, quote unquote. But from the query, there's none of that. The queries are sent anonymously. So from a viewing key, I can pull up the query for a viewing key, actually, if it's in here. Yeah, not the query for viewing key, but the balance query. So you pass in the address for the balance you want to. So you can really query for any address that you want to see the balance, but you need the viewing key, which this is actually not showing that field, the viewing key field. I think it's just key, and then you pass in the viewing key that you have set. Yeah, it just makes sure that nobody else can see your balance unless it's like a password. And there's also permits, which permits are way nicer. They're a little heavier load on the blockchain, because it's like a signed, like encrypted data that you sign with your wallet, so that you can basically stamp it, and then you can use it for all contracts. The contract doesn't need to know about your permit ahead of time, because when you send it, it can basically derive what the sending address is from the signed data. So if somebody got your permit, they could send it around and see all your balances, but it doesn't require an initial set viewing key transaction. So it helps with the UX a lot. So then I guess we'll go back to the contract. So SecretCLI, I'll show you my SecretCLI real quick. So this is the secret for configuration, chain ID, node. Those are the important ones. I don't think I've ever changed key read backend, output, or broadcast mode. I have seen the output being in different formats than JSON, and I prefer JSON. So if you get weird outputs, I'd recommend switching that. And the other thing that you're going to want that's a really good tool is called JQ, because when you query things, they come in unformatted. It just kind of dumps one line of JSON on your screen. So you can pipe everything through JQ to get nice formatted outputs. Consider that one a must have. So let me configure this for my local secret. CLI status, check and see if it's, yeah, see, there you go, there's that JSON. So do JQ. So it looks like it's all connected. So then in this, so this make build is something that you can probably expect in most contracts, which is really, it's just a make file. It's really nice to have. It's kind of good to understand what the steps are to build one, from the terminal, because there's a few things like optimization is a step that has given me trouble sometimes. We've had to change optimizers a few times. And I think the regular CosmWasm one doesn't like secret network contracts. You get weird opcode errors that are hard to, narrow down. Just take a second to build, but I can show you guys the make file in a second because it should have all those commands in there. Yeah, so then right in here, this does some symbolic linking, I guess. I'm not sure exactly what these Rust flags do, but the cargo build and then build for release. And then this is the target that you set up earlier for WASM32 so that it builds for the validator architecture or the smart contract environment. And then it's going to need, because this runs that, and then it runs compress, because they also need to be gzipped right here. So it grabs it because this target, Rust will just build it to the target WASM32 unknown release start out WASM location. So it just moves it up into the root. And then this is the gzip. Gzip-9, which I think is higher compression ratio. And then I'm actually not seeing the optimizer in here. Oh, it's commented out. So this is the optimizer step, which I suppose is optional, which is good to know. So I'd say, especially for early development stages, just ignore the optimization because it does take some time. But I think it just strips out and makes it a little leaner. I haven't looked into what the optimization actually does, but yeah, I'd say just skip it if you, if it doesn't seem relevant to your specific use case. But this is built through an LS. So we've got this contract.wasm.gz here. And this is what you're going to have to deploy to or store. The first step is called a store, where you basically take the code and just upload it to the blockchain. I'm going to do that now. This might take me a couple tries. It's been a minute since I've SecretCLI TX compute. So TX is an execute. You can do TX or query. TX, and then compute means you're doing interacting with smart contracts. Store, store contract.wasm.gz. Okay, and you might get this error sometimes. It's very unhelpful, but basically the issue is you need the -- from. And I think it's Oh, maybe it's only when you're on the Docker that you have the A. I can just use my. Okay, I think I need to use the be on the Docker. Let me try to pull that up real quick. This should have SecretCLI set up on it. Yep. And then keys show. So if you didn't catch that, this is the root on the Docker that's running the blockchain. So it has these keys already set up for you. And I may actually need to rerun that because there is I think it's actually in here. I should just look at this. Yeah. That's the optimizer. Oh, it's because the issue is it can't see any of the files that I have locally here. So it will not, I need to like link those or like share the. Where is, let's see. Sorry about this one. I gotta find how to share the storage with my laptop. Maybe we just do this the dirty way and. Nope, never mind. Do a quick Google for Docker.
Are you just trying to fund the wallet?
No, I got the wallet. I need this file. I need on the Docker container. There's a command that lets it like see the same files so that it can like share that folder. But I don't know it off the top of my head and didn't find it fast enough. So this should get me by for now. I'm just gonna copy paste it up. There, okay, so it should be here. Or not. It's in the root. Okay. So there I've got the contract wasm GZ on here. I'm going to use this A wallet. TX compute store contract.wasm.gz from A. It just wants you to confirm. You can do a -y to get rid of that if you want. So we got an out of gas, which is pretty expected because the default of 200,000 is pretty low. Go to 1 million since it's testnet money. So now we get this transaction hash. And this basically means that your request was successful and your transaction is in the mempool, which is like the queue when they're waiting to get executed. And then to see the output, you do SecretCLI Q, which is just shorthand for query, QTX, and then paste that TX hash there. And then you get that gnarly JSON. And you'll get a huge thing of a lot of these attributes are encrypted, which is secret network stuff. And what you'll find is when you query these, none of the output will be decrypted. Like there's this massive block. Sometimes you have to scroll through to see the actual output. And it is, there we go. So then up here, you can see, there isn't a direct success, but the fact that there's no error and then it gives you this code ID, this identifies that instance of the executable on the blockchain. So you'll use that code ID to instantiate. And this just increments, so that's why it's 1. So then the other thing that's good to know that is, I don't think we'll have super interesting output, but as long as you're the sender of the TX, as long as this is the device that executed, you can do a Q compute TX, and this will also only work for, or only give interesting output for smart contract interactions, because this will do decryption of the output. And it looks like this because there wasn't any smart contract specific stuff happening aside from the store. But normally it will, if you do like a STIP20 send, it'll give you all the logs for that. So now if we're going to instantiate the contract, SecretCLI TX compute instantiate. Oh, there's a typo. Instantiate code ID. So you want 1. You need a label, which it just shows in the contract metadata, but they have to be unique. We'll just call it counter. And same typo again. Oh, and then you also need the instantiate message. So it needs to be valid JSON, and it's kind of painful to type it in one line. Let's actually go look at what that message was again. So yeah, so it's just instantiate count I32. The other thing to note about CosmWasm is that since this is a native Rust data type, in the JSON it'll just look like count : 1. But a lot of the times you'll see this uint128 object, which is what they use to get bigger numbers. I believe and it'll come through as a string. That's the primary thing that you need to know. You'll have to use them a lot because there's some restrictions with these numbers that I don't know the full context on. But for this, now this will have to look like this. So it's something you got to keep track of, which is annoying when these are intermixed with uint128s and you have to juggle them. But this, I don't need all of that stuff. So count can be 3. I need that. Yes, this will probably fail for gas. I don't have less on here. Okay, well. And so here you can see from the raw log, and here also, they have a contract address. So that, is successful. Let's see if the Q compute TX gives anything interesting on this. Let me just mess that one up. Yeah, so the Q compute TX is way more brief. Tells me what the instantiate message was, and then tells me the contract address. Oh, this has to be a Q compute contract. So this will just show me the contract metadata, which shows you the creator, when it was created, things like that. One thing that I didn't do on this instantiate, I don't know if you guys have been tracking the secret network upgrades, but they just did a contract migration upgrade, which basically now you can deploy a new version of your code on top of the existing contract without having to do the pain of moving all the funds to a new contract to update things. And what you need to do to have that enabled is when you do this instantiate message, you have to do a --admin and then tell it the admin address. And if you don't do that, as far as I know, you can't add it later. So it's important to do that right away if you want that enabled. It won't be important for development, but it's, if you ever find yourself doing a production launch, that will be, it's important to do it. Yeah, so I've got the contract deployed, run a query, apply Q compute query to this address. And then our query message is get count. So we'll do a get count 3. Cool. So that all worked as expected. So we can do and then we can try this increment TX, which looks just like the query SecretCLI TX compute execute address increment. And then one thing you'll find that is kind of weird is that with all of these, you just have the open close bracket and you need that in there. There are different, I don't remember the syntax off the top of my head, but there is a different way to format these messages for one like this with no fields where it is just a string. I don't like to do it because I got so used to doing it like this, but it's just if you're wanted to do that. -- from a yes tx compute or q compute tx. Look at that transaction hash. So I mean, there's not really a success, which I usually have to look around for a little bit, but usually the errors will be pretty obvious in there if it had failure. So then we'll run this get count query again, and now it's 4. Perfect. It's pretty basic, relatively uninteresting example, but it's a good way to get your bearings with the deployments, and then to build from. It's it's not a terrible repo structure. And that covers most of the startup tutorial. Getting started on a contract. I didn't know if is there anything specific that you guys had questions about or were wondering? Or anything I didn't cover that you had hoped would be covered, or?
Sorry, I just realized my mic was off. Sean, is there anything else that you would recommend touching on as far as like introduction to secret WASM development? If not, Swinson, I think it would be potentially helpful to talk about some of the things that you have done in the past, setting up your dev environment to set yourself up for success, especially when you're building something that is a little bit more complex,
Yeah, so a couple of things. I mean, I'm sure you guys saw I use Vim a lot, which I don't know if that's going to be relevant to a lot of you guys. I know a lot of people like the JetBrains stuff. I've got like the Rust analyzer and things like that run on here. It hasn't been running. Sometimes it's a little finicky to get it working, but it'll do things like this. It'll tell me my errors. That's always nice, so you don't have to go back and build over and over again. I have found that these logs are not that useful. They're very difficult to find in this mess because every block is just spitting out junk. So you have to run it and then you have to like wait and hunt through this, and it's miserable. So I try, I haven't found these logs to be that useful. What I usually do is I use a print line and then whatever. And that also isn't super useful running it on the local blockchain. But then when you're running unit tests or multi-test, which is more of an integration for testing for smart contracts, then they show up and they're really helpful. And then the other thing for like, when you're just trying to find where something is failing, I usually will do this, just do a panic here so that I can see that it failed right there, because this panic will come through. You will get this message through from the CLI. So that's a good way to do, kind of like, not necessarily black box testing, but if you're just can run your code and you need to, you can't get these logs to show, I usually just tell it to fail there, and that'll get it done. The other thing to mention, in this receive message, one thing that has gotten people before, and there's actually been some other products that had major issues with this, is that you need to verify what token you're getting it sent from. So in this, so we get this receive message. There's a sender, which is the user that sent the funds. And then there's the from, which I said before, the difference is the allowance. Basically, if you give an allowance of somebody, the person you gave the allowance to sends those funds. The person who owned the funds is the from, and the person with the allowance that sent it was the sender. Otherwise, they'll be the same address. So it's kind of difficult to decide which one you want to use. I think we always used the from field, but that's, we haven't run into any issues with that. But the part that's can be tricky is that the token is the TX sender. So this message info up here, this let me just make these a little flatter. This message info is how you're going to determine the token. So if you have your expected token, you're going to want to make sure, like, if expected token does not equal info.sender, you're going to want to return an STD error. And you're going to want to do this no matter what, even if you're only expecting one token, because like I said, even if you don't register receive to a token, somebody can send funds to you and give your code hash, and your receive will be called. So it could be from some token that you've never heard of or seen before or care about. And so then, you can spin up some random token, send it in, and the contract will be like, oh, this is USDC, and just accept it. And you can, it would totally ruin the whole thing. So that's a really important thing to keep track of. And then you're going to want the register receive. The other thing that we're having to add because of migrations is to update code hashes, because when you migrate, you get a new code hash, and you have to use the new one. So the old contracts with the old code hashes will start failing. Another thing that's not important for like proof of concept building, but it's good things to think about. It's hard to say what else there is in here that, since the contract is so slim, I can go to the shade repo. Actually, I don't even know what would be in there that I would show. This is, I usually like my tests in a different folder than in the source folder. Obviously, this is just a template. And also this kind of testing, it sort of works when you only have one contract that's working independently. But then they don't get you very far when you want to do complex interactions. So if you're, had a token deployed with your contract with the Oracle, you're going to want to use multi-test, which is our CosmWasm tool that we've ported over to Secret Network. And it lets you, run like an emulated blockchain, and it'll actually execute the transactions. And it's just far more in depth, and you don't have to mock as much stuff to get it to work. Writing the test can be a little clunky, but they work really well. Trying to think what else I use. having your configs organized and having tooling to switch between testnet, local, and mainnet is really nice. Fiddling with those configs manually is painful. JQ, I said that before, but JQ is I think critical, just because looking at unformatted JSON sucks. Yeah, I think that. If you're sending a transaction, I'm sure that you saw over here typing this one-line JSON on the CLI works for these cases, but then when you have like three levels nested of JSON, and it's longer, what I will usually do is just open a file. So just write some JSON to it. And then when you do a JQ, so then it's valid JSON and it shows it formatted, and you can do JQ-C, and then it gives you the one-liner to copy paste in there. And that's what I'll do, especially because even just a snip20 send from the CLI gets pretty clunky and bulky on the command line. Yeah, I don't know if I have anything else that's quick to get started. I'm sure something will come to me right after this meeting. But I'm also happy to answer any questions or any. Sure, if you guys run into an issue on this, I've already run into it before, so I can hopefully help.
Yeah, this has been a great introduction. I'm looking back through our proof of concept requirements, and if there's anything that stands out that you think would be helpful, just let me know. Effectively, we're gonna, for this proof of concept for the perpetual swap hackathon, you're gonna have a few different smart contracts that are interacting with each other. You're gonna have the actual perpetual swap contract that allows you to place limit and market orders for long and short positions, and users are gonna need to be able to interact with that to open, modify, close positions, and then you'll have with the design of this perpetual swap exchange that we're wanting to make, you'll also be interacting with liquidity pool or AMM contracts. This is actually where the funds are effectively being stored to actually interact with via the perpetual swap contracts. And users are able to provide liquidity to these contracts, depositing assets. Should be able to make general swaps in the LPs, but it's mostly to facilitate this longing and shorting. And then you'll also have a price feed source. So most of the time when people are thinking about this, they're thinking about oracles, but there's also like with GMX, they actually use price feed contracts that aggregate a variety of oracles and push those on chain. So I don't know if there's anything you can think of that would be helpful for like when you're trying to get one smart contract to interact with another smart contract. Anything that you think would be helpful from an introductory perspective?
Yeah, so I suppose for the Oracle, the main thing that you're going to need is the get price query, which we have things in the Shade repo that you can import to get those messages. That some of that stuff needs some work, and they're super simple. So a lot of the times it's easier to just re-implement a quick enum that has the structs that you want. A different query message struct for the Oracle, but then you're also going to want a field like this in your instantiate message. This contract info comes from Cosmwasm. And it basically looks like address code hash. So once you have both of those, you really just need the address for querying. But once you have those, then you're going to do a query to the Oracle that looks like get price. Here, let me just actually do a real Oracle query if I can find the Let me stop sharing my screen for a second. Find the real Oracle address.
Yeah, I appreciate you going into this. Just for anyone listening now or listening in the future, we're going to be hosting a workshop specifically on price feeds and oracles, and we're going to be having a workshop presenter from Oho, which is a Oracle provider in the Cosmos, going to be leading that workshop. So we will be going into this more in depth in the future. It's just helpful for people getting started off.
Yeah, there's one specific thing that, so I'm gonna switch to the mainnet. This is a little alias that I have set up to switch to my mainnet config. So Q compute query, that's the Oracle address. So we have an Oracle router, and there's a bunch of other contracts underneath it for doing the more specific price, like derivation types, like either from the DEX or from band. We use band for a lot of our data to get price. Key BTC. Let me format that. Okay, so last updated base and last updated quote. The base, I might have this backwards, but basically the base is BTC and the quote is USD. Because with band, it lets you pass in whatever you want to those. For our Oracle purposes, we always use USD. So this just tells you when those prices were last updated from the source. It's good to check them. I'm not sure why these are so different. This would be one thing to look into. But then this is the price. So if you're using our Oracle and not directly from band, it'll always be in the USD, and it's always with 18 decimals. So I'm not going to count them out, but basically that should be at $37,007. And this is also the difference between those I-32s, the native Rust types, and the uint 128. How this one's in quotes and this one's not. But yeah, you trim this to 18 decimals, and that'll give you. That's how we do a lot of our math in the contracts, because you can't use floats because they're so inaccurate. So we just use the integer math. And when you want to get decimals, you basically just add a bunch of zeros. So if you have 100 for 100, or like 1 for 100%, you could scale it up to 18 decimals, do all your math with it, and then scale it back down to where you want it to be. A little bit painful sometimes, but that's how you got to do it in the smart contracts. But that decimal thing was the main thing I want to show you. The prices from Oracle will always be 18 decimals. And then, yeah, I think unless anybody's got any questions, I think that's all I've got.
If no one's got any questions, I can say thank you, Jackson, for presenting today and hosting our first dev workshop. I think this was really comprehensive. We've got a few of our mentors in the audience right now. For anyone listening to this live or listening to it afterwards, if you have any questions, about smart contract development, Oracle's front end, really anything throughout this development process, please reach out to our mentors in the Shade Discord. There's going to be a link in the YouTube video directing you to the dev channel within the Shade Discord, and that's where you'll be able to interact with all of our mentors. We've got a special role for mentors, so you just will need to @Hackathon Mentor, and we've got, I think, 5 or 6 different mentors that'll be available to answer any questions. So I'm going to be more than happy to help out anyone who has any questions throughout this, but I think you provided a really great introduction, Jackson.